Okay, this is the second part of lesson 27, which is still on polar coordinates. So you're going to be asked on your test to switch from polar to rectangular or from rectangular to polar. So rectangular is an equation that just has x and y. And a polar equation is going to be an equation that has r and theta. Okay, so there are three different equations that you need in order to switch from rectangular to polar or polar to rectangular. So I know I wrote this a little bit funny in your notes, but you could have all three different equations. So these are the three that you need to know. So the first one is that x equals r times cosine theta. The second one, oops. The second one is that y is equal to r times sine of theta. And then the last one is that r is equal to the square root of x squared plus y squared. In other words, r squared is equal to x squared plus y squared. Okay, so for the first one, these first examples are in rectangular form. So they all have x's and y's, and we want to switch it so that everything is in terms of r and theta. So if you have x equals 4, we can replace x with r times cosine theta. So what we really have is that r times cosine of theta is equal to 4. So if you solve for r, which most of the polar equations will be solved for r, you will get r equals 4 over cosine theta. In other words, r equals 4 times secant theta. Okay, part B. So I have x squared plus y squared equals 36. So we're very lucky because we have x squared plus y squared. And remember that x squared plus y squared is equal to r squared. So in this equation, we have r squared is equal to 36. Now, if you think about polar coordinates, if you have r, like this means that r is equal to plus or minus 6. If you have r is equal to 6, should have done a smaller number, that means that you have a circle, right, with a radius of 6, so it's going all the way around here. So if you have r equals negative 6, well, it's really the same circle, because if r is equal to positive 6 or negative 6, right, it's really the same distance from the origin. It's just, remember when we had like negative 3 comma pi over 2? That's like saying go along the pi over 2 line, which would normally be this way, but instead we're going negative. So we're going to go 1, 2, 3, and it would actually be here. Okay, so having r equals negative 6 is really the same thing as r equals 6. So we're just going to say r equals 6 because it's a little bit redundant to have both. Okay, and then on this part C, we have x squared plus y squared. So we know that x squared plus y squared is equal to r squared. So I have r squared minus 7y equals 0. But I'm not done because I don't have everything in r and theta. So now I need to replace the y with r times sine of theta. So we have r squared minus 7r times sine of theta equals 0. And what we're actually going to do on this one is we're going to pull out the common factor, which is r. And if you think about setting each piece equals 0, if you had r equals 0, right, that's just going to be the pole, or the origin, as you might think of it, right? R equals 0 is just saying on your polar form, you just have that point right there. But this is not just the origin, right? Right, you can't, it's more than that. It actually ends up being like a hyperbola, well, not a hyperbola, it ends up being an ellipse. If you think about your algebra 2, like x squared plus y squared equations are the ellipse equation. Okay, so it's not the origin. Okay, so what happens is it's going to be this equation, which is r equals 7 times sine of theta. And this is the one that we're looking for. Okay, so you actually, when we have something like that, if we can pull out the r equals 0, that's not what it is. It ends up being the r sine of theta. And you can try to graph it to see if you use like Grapher on your computer. So if you open up Grapher, all of you have that on your computer, and put in x raised to the 2 minus 7y plus y to the 2 equals 0. And you will see that it is an ellipse. And it ends up being this one. So you can check on your graphing calculator with polar coordinates. All right, so that's how we switch from polar to rectangular. So let's go from rectangular to polar. And this method is a little bit harder. So if I have r equals 10, r we know is the square root of x squared plus y squared equals 10. So what I would probably do is write it as in like the most familiar form possible. So if you square both sides, you'd have x squared plus y squared equals 100, which we can see is a circle. Okay, if we have r equals 12 cosecant theta, well, we know that if we divide by, we're kind of close to the form that we know. If we divide by cosecant theta, we get r times sine of theta equals 12. And r sine of theta is the same as y, right? So we get y equals 12. Okay, so the first one was a circle, part A. This one, y equals 12, ends up just being a horizontal line, right, through 12. All right, so the next one. So if I have r plus r cosine theta, r is the square root of x squared plus y squared. And then r cosine theta is just x. So we have the square root of x squared plus y squared equals, or the square root of x squared plus y squared plus x equals 4. And if you really wanted to write it in a different form, what you could do is you could subtract. I'm fine with leaving it this way. But if like Math Excel asks for another form, you could subtract over and then square both sides. So you'd get 16 minus 8x plus x squared equals x squared plus y squared. And then if you subtract the x squareds, it goes away. So you get y squared equals 16 minus 8x. So now when you see it in this form, you can really tell that it's going to be like a parabola on its side, if you remember from Algebra 2. So that's really kind of a nicer form, I guess. All right, so the next one. So if I have r minus 3 cosine theta equals 7 times sine theta, we know that if we have r sine of theta, we know that's y. And if we have r cosine of theta, it's x. And we're almost there here, but we're missing r's, right? So what we're going to do is we're going to multiply both sides of the equation by the same thing. We're going to multiply through by r. So we're going to have r times r minus 3 cosine theta equals r times 7 sine of theta. And when we do that, we get r squared minus 3r cosine of theta equals 7r sine of theta. So r squared we know is x squared plus y squared. And then we have 3 times r cosine theta. Well, that's going to be 3 times x equals 7 times y. Okay, and then we can leave it in this form. That's fine. Or you can move it around if you wanted to. But you should always be thinking about, like, what form is this in the end? Like, what shape will this make? So since you have an x squared and a y squared term, it's either going to be an ellipse, a circle, or a hyperbola. But since they're both the same, since I have 1 x squared plus 1 y squared, it actually ends up being a circle. So this is the form of a circle. So there are other things that you could do to get it like in standard form. So, you know, if you were in a pre-calc class that was longer than just the summer, I'm sure what I would have you do is I would have you rearrange and then have it set equal to 0. And then you would complete the square to find the numbers that go here, just so you could get it to be in that like standard form, which would be the x minus h squared plus y minus k squared equals 0. So I think Math Excel will accept this form, so we'll just go ahead and leave it like that. And on your test, you can leave it like that too, that's fine. All right, so the next one, so I have theta equals pi over 4. So this is a tricky one. Okay, so I didn't give you like an equation where if you had theta, you could replace theta with something. So I gave you 3 equations. I said x equals r cosine theta. I said y equals r sine theta. And I said r squared equals x squared plus y squared. So really, if you see the theta equals problems, what I want you to do is I want you to think about the graph. So we talked about graphing in section 27, part 1. So if you have theta equals pi over 4, that means that you have 0 comma pi over 4, 1 comma pi over 4, 2 comma pi over 4, and so on. And you're also going to have negative 1 comma pi over 4, and so on. Okay, so you're going to have all these points along one line. So if you think about what line that is in the xy coordinate plane, I think it makes a lot of sense. It's just the line y equals x. Okay, so that is the easiest way to switch forms if you just have theta equals a number. So I wanted to do one more, just in case, you know, if you had another one. So let's call this part G. So what if you had like theta equals pi over 6? Well, pi over 6, that means that you're going to be along this line right here, the pi over 6 line. And we know it goes through the point 0, 0 for the rectangular coordinates, but we don't know m. Okay, so we don't know the slope of the line, but we can figure it out. So if you think about how much it rises and runs, right? So let's say we have a point right here, out 1 unit. Then it's really just a unit circle value. It's saying you go out root 3 over 2, up 1/2. Well, that means that's your slope, right? Your m is going to be the rise, which is 1/2, divided by root 3 over 2, which is 1 over root 3, which is root 3 over 3. So if we talk about y equals mx plus b, it's going to be y equals n x, and then b is 0. It goes through the origin, 0, 0. So that is the way that you would switch forms. So the question is, well, how do we get this root 3 over 3 thing? And what we did is we did the y value divided by the x value. So the slope is always the tangent of your theta, okay? So if you ever need m, you just are really just doing the tangent of theta. Okay, so this next one, so if I see r equals 2 sine of theta. So these are the trickiest ones for students. Because they know that if they had r squared, they would be good. They know that r squared is equal to x squared plus y squared, and so they really just try to square both sides, and they think that that's going to lead them in the right direction. So what they try is, like I said, they try to just square both sides. Okay, but then that gets them to 4 sine squared theta, and it really doesn't help at all, because you don't have r sine of theta. You can't replace it with y. So I don't want you to square both sides in this situation. I want you to think about another way that you can get r squared. So what you can do is you can multiply your equation on both sides by r. Okay, so that's what the trick that you need to kind of keep in your back pocket for these ones. You just need to multiply through by r. So you get r squared equals 2r sine of theta, because then you're almost done. So then r squared is equal to x squared plus y squared, and then 2r sine of theta is going to be 2 times y. So that's going to be your equation. And again, that's a circle, because I know I have 1x squared plus 1y squared, so I could get it in that standard form if I want.
Polar equations for conic sections. So this is kind of an interesting lecture. We've talked about this before when we switch from polar to rectangular, that sometimes you can get a circle, or you could get an ellipse or a hyperbola, but we didn't do a lot, like, I mean, in our review of conic sections, remember we did complete the square and so on. We didn't do a lot with switching things from polar, getting it in rectangular, and then switching into a common form. Okay, but these ones, we're actually going to keep it in the polar equation, and we're going to graph. So you definitely want to have your calculator out. For this first part, we have this little box here. This box, if I ask these questions on your test, you'll have this box. So everything that's in there, you will have. Isn't that exciting?
Thank you.
I know, so very nice. All right, so you have all the formulas that you'll ever need to know right there. All right, so as we're doing these, and this is how I set up your homework too. I was going to just do book problems, but I went ahead and made like a worksheet, and I have it set up so that there's 4 steps that you're going to do every single time. So the first thing that I want you to do is I want you to find 4 important points. So you're going to do like a little table, and I already have the table set up on your homework with theta and r. And I want you to find intercepts. Well, with polar coordinates, if you're trying to find an x-intercept and a y-intercept, it's kind of weird. Like, we don't talk about x and y. But we can talk about at theta equals 0, right? So theta equals 0, pi over 2, 3 pi over 2, or not 3 pi over 2, pi and 3 pi over 2. So we can talk about how far we go along each of these and where that point is going to lie. Does that make sense? So that's kind of where you're going to get your intercepts in polar coordinates. So as you're doing these, I want you to do 0, pi over 2, pi, and 3 pi over 2. And you can do these in your head, I promise. Yes, Ben?
You have an extra lesson?
I do not. You're just going to have to take it on a piece of paper. Man, rough. All right, so as you plug in 0, so kind of do this in your head. What's cosine of 0?
0.
1, right? Unit circle. So it's over here. Cosine of 0 is 1. So if you have 8 divided by 3 plus 5, what do you get? 1, right? 8 over 8 is 1. Now if you plug in pi over 2, what's cosine of pi over 2?
0.
0. That one's 0, right? So you have 8 over 3. So we're going to leave it as 8/3. How about pi? What's cosine of pi? -1, right? So you're going to have 8 and then over 3 minus 5. So 8 over -2 is -4, exactly. And then you're going to have 3 pi over 2. When you plug that in, you get 0 again. So you're back to 8/3. Now, I fully expect that you guys can plug those in and graph those points without your calculator. Those 4 you can do, definitely. I think you would be fine. So remember your polar graph looks like this, and so on. So if I have 0, 1, what that's saying, it's really the point 1, 0 in polar coordinates. We always do r theta. So if I have 1, 0, I'm going along the 0 line, like this line, and I'm going out 1 unit. And if I have 8/3 pi over 2, I'm going along the pi over 2 line, so this line. And I'm going out 8/3. So 8/3 is a little bit more than 2, right? So you're going to go 1, 2, somewhere around there. It's actually 2 2/3. Maybe I should make it look a little bit better. We'll do it up there. All right, now pi, -4. So if you go along the pi line, you're going back -4. Do you guys remember how to do that? We did that at the beginning of the chapter. So you're going to go back. 1, 2, 3, 4. It's going to be over here. And then I have 3 pi over 2, 8/3. So along the 3 pi over 2 line, I'm going to go out 8/3, just like that other one. Okay, so we want to know what shape we have, and it's always kind of strange. Okay, so we want to identify 3 different things. So we want to identify K, A, and B. Okay, K is always the number on the top. Okay, so what's K in this case? 8, exactly. What's A? 3, and B is 5. And you have this little cheat sheet here. So it says if absolute value of B is less than absolute value of A, then your graph is going to be an ellipse. If absolute value of B is greater than absolute value of A, then it's going to be a hyperbola. And if absolute value of B is equal to absolute value of A, then the graph is a parabola. All right, or you could use the eccentricity, so I have those there as well. So if I find the eccentricity, I'm going to do 5 over 3, the B over A, and I get something that's greater than 1, right? 5 over 3 is bigger than 1. So what will we have? What shape? A hyperbola. Now, basically, based on those points, I can kind of tell it's going to be a hyperbola. Because it's like, wait, how do you make an ellipse with those points? Or a parabola, right? It's got to be a hyperbola. And for all of these problems, you will always have one of your focus points at the pole. Do you guys remember the pole is like the origin in polar coordinates? So you're always going to have one focus right there. So do you guys see that we're definitely going to go this way? And then the other one's going to open this way. Do you see it? Any guesses on where the other focus would have to be? Yeah, it's going to be to the right of that last vertex, right? It's going to be to the right by 1 unit. So if we call our focus points, the first one, I just didn't even spell focus there. I don't know what I was doing. Our first focus point was at the pole, 0, 0. The second one is going to be along pi.
How do we know it's that?
Because it's always that. The one focus is always at the pole.
Oh,
So the other one ends up being at pi comma negative 5. So it's going to be right there. So we're always staying along the 0 line and along the pi line. And that's going to happen whenever we have a cosine in our problem. Now if we have a sine in our problem, it will end up being along the pi over 2 line and the 3 pi over 2 line. But you'll see that as you're graphing it. So let's use our calculators. So everybody get your calculator out. You need to be doing this. Okay, we're going to go to mode. We're going to put it in radian, and we're going to put it in polar coordinate mode, so polar. So everybody should be doing that.
You have to
Pull, Paul.
Oh, never gets
All right, so as I'm putting this in, I'm going to have 8 and then divided by, I want to put the whole denominator in parentheses. So I'm going to do 3 plus 5 cosine of theta, and that's all going to be in one big parenthesis. You guys see how I put a little parenthesis there?
Should we put 2 parentheses?
Yeah, like the theta will automatically put another parenthesis, so you'll need a 2 parentheses at the very end. You guys see? All right, now I go through a process whenever I'm graphing these because I like for every square in my grid to be like an actual square, not a rectangle. Okay, so what I do often is I'll do zoom, and I'll try zoom fit. Zoom fit is handy sometimes. Ooh, there's lots of zooms on this calculator. Look at this. So basically from your very beginning, you're going to keep going down until you get zoom fit. Do you guys see that? It's something that we use a lot in statistics, but we don't use as much in our other classes, but they seem to work pretty well for these. So hit enter. But when you hit zoom fit, it's not going to give you those little square shapes that I want. So after I hit zoom fit, I often will do, well, maybe it's not going to do.
Should we be in radians or degrees?
You should be in radians.
Okay, that's what I thought.
Then I do zoom square. Mine's still thinking. Let me check my window, actually. Maybe the window's still in degrees. Hang on. So let's do zoom standard first.
Okay, that's what I got. Is this what it should look like?
Okay, so do zoom 6. Okay, you guys can kind of see it there. And then I want to make it like square. So I'm going to do zoom square, which just makes all of my little squares actually squares. So you can tell how wide it is. Okay, did you guys see that? Did you do zoom standard first? Do that first. Zoom 6. So I think whenever you're graphing these, do zoom standard first. So it's going to do the 0 to 2 pi instead of 0 to 360. Because the 360 was making it take forever. It's doing it in degrees. You want radians. All right, now can you verify these points? Doesn't this look like 1, 0 in the rectangular coordinates? Yeah. What's this point look like? You can kind of find it. It's going to be 1, 2, 3, 4, right? You can find those different points. And if you aren't sure, then you can always zoom in. My favorite thing is the zoom box. Have I used zoom box with you guys? Okay, when you want zoom box, you go to a random corner and you're like, oh, I kind of want my box to start here, and then I'm going to go over. I don't hit enter again until I go all the way down. And so it's like I want just this particular area, and you can hit enter. So then I can see it's definitely at 1 and then 4 for the vertices. Does that make sense?
That's cool.
Yeah, we like zoom box. It's a good one. All right, so I have lots of questions. So the first step on your homework is you do the little table, plot those points by hand. You can handle those. Then you graph it. So that's step 2. I guess you should also find what shape it is, right? Then you're going to change it into rectangular form, and then you're going to graph it using rectangular form as well. Okay, so that will be your homework, but we're going to do some other things. So our formula was, or not a formula, our equation was r equals 8 over 3 plus 5 cosine of theta. So let's write that down. And we're going to change it from polar form, which is r's and thetas, into rectangular form, which is x's and y's, right? Do you guys remember that? So we're going to do r times 3 plus 5 cosine of theta equals 8. So I'm going to do 3r plus 5r cosine of theta equals 8. Do you guys remember what r cosine of theta is?
Y.
X.
X.
Do you remember what r is replaced with? Good. Square root of x squared plus y squared. So we have 3 times the square root of x squared plus y squared equals, no, plus, it's too speedy, plus 5x equals 8. And when we first learned this, I kind of let you, for the most part, leave it like this, but I'm going to actually have you solve for y, if possible, or get it into a common form.
Oh.
So if you, like, we know it's going to be a hyperbola. So hyperbolas, if you remember, were always equal to 1, and it had a bunch of stuff like x minus h squared over a squared. We're going to try to get it in one of those common forms, okay? So first thing I'm going to do is I'm going to subtract the 5x over. Might want to kind of write tiny. We have a lot of steps left.
Why can't we just divide by 8?
And we're going to divide by, well, because that's not going to help us get the form that we want. We're going to divide by 3. So we have that. We have to get rid of a square root because we don't have square roots in our hyperbola equations, do we? So I'm going to do squared to both sides and square both sides. You with me? We did this kind of stuff in algebra too when I always said isolate the root. You always isolate and then square. So you're going to have x squared plus y squared equals, and you're going to square the numerator. So if you need to, off to the side, write 8 minus 5x times 8 minus 5x, you can do that, and you can FOIL it out. You would get 64 minus, the outer would be minus 40x, and the inner is also minus 40x. So minus 80x plus 25x squared. But what about the denominator? What do we get down there? 9, exactly. Right, square the 3, you get 9. Still with me so far? This is just algebra. We did this last year. Causing fear in your heart, panic. All right, we're going to multiply the 9 over. So we're going to have 9x squared plus 9y squared equals 64 minus 80x plus 25x squared. And we're going to try to get it into the hyperbola form. Okay, so we're going to get everything except for that 64 on the other side. We're probably going to have to complete the square. That's why you don't have very many of these homework problems. You only have 4 things that you're doing. And we're going to solve. So when I subtract that 25x squared, I'm going to write it as 9y squared minus 16x squared, right? 9 minus 25 is negative 16.
Oh, yeah.
And I'm going to have plus 80x equals 64. And I'm almost there. Do you guys remember when we completed the square? What's the next step?
Try to get the
We can never have like a 16x squared at the beginning when we're completing the square. It always needs to be a 1x squared. Does that help you? So we're going to do 9y squared minus 16 in parentheses. So when we pull out that 16 from the x squared and the x, we're going to have x squared minus 5x. Now we can complete the square. So we're taking this negative 5, we're dividing by 2, and we're squaring it. So what do I get when I do that?
2.5.
You guys are always doing decimals. Fractions are your friend. X squared minus 5x plus 25 over 4 equals 64 plus, it's not going to be 25 over 4, it's going to be negative 16 times 25 over 4. So let's find that. So if I do negative 16 times 25 over 4, the 4s and the 16s, or the 16 and 4 will reduce out. You'll get negative 100, right? That's what we really, that was the this times this. Almost there. I have to go down here, man. So I have 9y squared minus 16. I've now completed the square, so that should be something squared. And then I have equals negative 36. So what's going to be inside parentheses? Yeah, x minus 5 over 2. So one last step. When you have a hyperbola, you need it set equal to 1 at the end. So what do? Divide everything by negative 36, exactly. And as I do this, I'm actually going to rearrange. Because when I do it for the first one, see how I have 9y squared over negative 36? That's going to reduce down to y squared over a negative 4, which we never have negative numbers for our a squared and b squared. So I'm going to put that part second. Maybe I'll write that out first, though. Y squared over negative 4. And then I have minus, or plus, I'll let you use decimals if you want. This one is a little messy. I made sure the homework ones were nice. So you will get 2.25 when you do 36 over 16. Kind of go from the bottom up. X minus 5 over 2 squared equals 1. So do you guys see, like, I don't like writing that negative part first because you can't tell it's a hyperbola, right? It kind of looks like an ellipse right now because there's a plus in between them.
Negative 16 over negative 36.
36 divided by 16 is what you're doing because you need it on the denominator. You need the reciprocal of that. Like if I had 4 over 20, what would you do as you reduce?
1/5.
Right? So the 5 goes on the bottom. Does that make sense? That's what I did. So I did 36 divided by 16 to find 2.25, and I put it on the bottom. All right, so last step, I switch these two. So I'm going to write it as x minus 5 over 2 squared over 2.25 or minus y squared over 4 equals 1. Okay, and that would be in the form of a hyperbola. But like I said, you don't have like fractions and decimals on your homework ones. I think I tried to make them all nice, so they should be good. Yep. And then the last ones we've already found. So we found the eccentricity, right? That was 5 over 3. And we said it was a hyperbola because of that.
What is eccentricity?
Eccentricity for an ellipse would talk about how circular something was, but for a hyperbola I mean, it's not really like something that you can visualize, I guess. It talks about like how wide it is, basically. And then the vertices. So your vertices, we had this one, and we have this one. But since you have cosine in your problem, you always want to write cosine ones as 0 something and pi something. If you have sine, like I talked about, they'll end up being like vertical ones. So we're going to have 0, comma 0. No, not 0, comma 0. Sorry, 0, comma 1, right? You went out 1 unit along the 0 line. And then along the pi line, we went back to the right. So it should be pi, comma, negative 4. So that's how we write our vertices. And then where's the other focus? We already talked about that. The other focus is pi, comma, negative 5. Because the one focus is always at the pole. It's always 0, 0. Okay? So personally, I think, you know, polar coordinates are kind of nice. Doesn't this equation look much nicer than the other equation? It does. So kind of depends on what you prefer. All right, so this one. So consider the polar equation. So we're going to go through the same steps. So we're going to find those 4 points. So see if you can find them along with me. So we're going to plug in theta equals 0, pi over 2, pi, and 3 pi over 2. And all of these will, like when you're plugging them into sine, it will either be 0, 1, or negative 1, right? So what is sine of 0? 0. So the first one, we're going to get 10 over 3. Sine of pi over 2. Like, think about your unit circle. Sine of pi over 2 up here. It's 1, so I have 10 over 5 is 2. Pi gives me 0 again, so I'm back to 10 thirds. And 3 pi over 2 gives me a negative 1, so I'm going to have 10 over 3 minus 2. So I have 10 over 1, so I get 10. It's a little harder to sketch because we go out to 10, but we'll do the first couple rings here so you can tell. So we're going to go 1, 2, 3. So I'm going to have, well, let's do 4 since we have 10 over 3. Okay, so along the 0 line, we're going to go out 10 thirds. 10 thirds is 3.3 repeating, right? 3 1/3. So I'm going to go out to like right here. Along the pi over 2 line, I go up 2. Along the pi line, I go out 10 thirds. So again, right around there. And then along the 3 pi over 2 line, I go out 10. So do you guys see it's going to be way down here? So that's, we write it as r theta, 10 comma 3 pi over 2. It's kind of weird because like the thetas are what you're plugging in, so on the t-table I always put it first. Okay, what do we think it looks like? Not quite a circle. I think it's going to be an ellipse, right? It's kind of long. All right, and we can always tell that because we can find the eccentricity. So can you recognize K, A, and B? K is the top one. A is the first one on the bottom. B is the second one. So if we take the absolute value of A and B, I mean, they're both 3 and 2 anyway. Look at it. So when we compare them, is B smaller than A, bigger than A, equal to A?
Smaller.
It's smaller, right? So that's why it's an ellipse. Okay, you could also find the eccentricity, which we're going to find later anyway, which is B over A, which is less than 1. So when we graph this, it should kind of follow the points that we have there. So as I go to my y equals equation and I start putting in this formula or this equation, I have 10 over parentheses 3 plus 2 sine of theta. So are you noticing that the sine things are vertical and the cosine things are horizontal? So we hit graph. You can try the zoom fit since we've already done the standard. It might kind of center it. But every time I do like zoom fit or something, because see how that looks horizontal when I did zoom fit? After I do it, I always do z-square because I know this should be a long one. So the zoom fit kind of moves it around to kind of center it, and then putting it as a square shape helps. So you can see it, and you can verify all of those points. All of those points are correct. Yep. Okay, now do zoom square. Yeah. When you do the zoom fit, it sometimes makes it look like horizontal when it should really be vertical. So what's happening is like your calculator screen is like making these units longer than maybe these units. Does that make sense? So we don't like that. We don't like them to not be the same like distance. So that's why we do zoom square then. All right, so we sketch it in. Oh, mine's struggling. It's looking kind of like an acorn. All right, so we always have one focus where? At the pole at 0, 0. So how many units away was it from the vertex? It's kind of a, yeah, it's like 2, right? So we're going to go up 2 to get the other focus. So those 2 points are going to be the focus. So basically we graphed this by hand. We really didn't need our calculator. Our calculator just kind of confirms our results. Sometimes it's nice to have the calculator. Sometimes you're like, where are these points going? All right, so show algebraically that the graph is an ellipse by transforming into rectangular form. So this is the hardest part of the homework. It involves completing the square, which you guys did last year. We are mathematically mature enough to do this. Can you handle it? You're like, no. It means that you have had enough math in your time here to be able to handle this. So I'm multiplying the denominator over. I start replacing with things. So I'm going to replace with x's and y's. So I'm going to have 3 times the square root of x squared plus y squared plus 2 times what? Y, because you had r sine of theta. R sine of theta is y, equals 10. So this will be easier than the first one. You've had a little bit of practice. We have to isolate the root. So we're going to subtract the 10y over, or the 2y over, and we'll also divide by 3. So that we get our square root of x squared plus y squared by itself. We're going to square both sides. And we FOIL, so if you need to go off to the side and write 10 minus 2y times 10 minus 2y, you can. When I was in high school, I had to do that. I couldn't do it in my head. So I'm going to have 100 minus 40y plus 4y squared, and it's going to be all over 9. We're going to multiply the 9 over. So we have 9x squared plus 9y squared equals 100 minus 40y plus 4y squared. So when we reviewed completing the square, what we did is we got all of our x's and y's together and we left the number, the plain number, on the right-hand side. So I'm going to get all my x's and y's together. So I'm going to have 9x squared. I don't have an x term. And then I have plus 9y squared minus 4y, or minus 4y squared. So what do we get? 5y squared? I thought I had made this one nicer than the last one. Okay, 5y squared. And then plus 40y, right? Equals 100. So this one does not have those terrible fractions like the last one. So we're going to complete the square. So I need to pull something out. Do you guys remember? Yeah, the 5. So I have 9x squared plus 5. And then I do y squared plus 8y. You can leave a little blank there if you want. Equals 100 plus something else. So when we complete the square, we do b divided by 2, and we square it.
16.
Yeah, so we're going to have 16, exactly. You guys remember that? So b divided by 2 squared goes here. So what did we really add to that side of the equation? Yeah, 5 times 16 is 80. You still with me?
Where'd you get 80?
I did 5 times 16. So I have 9x squared plus 5. This should now be something squared equals 180. Is
Y
it?
plus 4.
That's y plus 4. Good. Louis is mathematically mature enough to handle these. He's on it. He's answered all my questions. Is anybody else going to challenge him? No. Divide by 180, divide by 180, divide by 180, and we're going to reduce. So like 9 divided by 180 is 1 over 20, but we're just writing a 20 on the bottom, right? So I'm going to have x squared over 20. If I do 5 divided by 180, right, what I typically do is I do 180 divided by 5, right? So when I do that, I get 36. So I'm going to have y plus 4 squared over 36, and then equals 1. Do we all recognize that that is an ellipse?
Mm-hmm.
It is. Would you be able to graph that ellipse? Sure. Where would the center be? 0, comma, -4. That's exactly where the center is. It's just in polar coordinates. And then from there, you would go up and down 6. Does that make sense based on our picture? You would go right and left the square root of 20. That one's not on our picture, but for the most part, you would be able to graph it. It would look exactly like that. It would just be on a rectangular like the Cartesian coordinate plane, right? All right, eccentricity we already found. So eccentricity we said was 2/3. The vertices, we're going to write it as, I don't know why I did a big, huge parenthesis there. We're going to have pi over 2 comma something. Dang it, I did it backwards. I always want to put the thetas out front, so I just have to think about it. And then 3 pi over 2. So how much do I go up along the pi over 2 line to get the first one? 2. How much did I go down along the 3 pi over 2? 10, right? The other focus?
-8, 3 pi over 2.
Yep, close, but it's not negative. It will be +8 because you're going in the positive direction along the 3 pi over 2 line. It's confusing, isn't it? Because you want to be like, oh, it's 0, -8. All right, good? Any questions on that? Okay, we're going to do one more. Guess what shape this is going to be? No. It's going to be a parabola. We've done an ellipse and a hyperbola. This is going to be a parabola. All right, so consider the polar equation. So we're going to go ahead and have our theta and our r. Is it break time? Is that what you guys are getting antsy for?
Mm-hmm.
It's not break time yet, right? We still have some time. All right, so we're going to plug these in. Can you all do this in your head? Remember, you could also do it with the t-table on your calculator, but I think you can handle this on your own. So if you plug in 0, cosine of 0 is 1. So you have 6 over 2, which is 3. If you plug in pi over 2, cosine of pi over 2 is 0. So you get 6 over 1 is 6. If you plug in pi, cosine of pi is -1. So what happens with pi? Undefined. That's a weird one. So we don't have a point along the pi line. And then 3 pi over 2, you get 0. So you're going to have 6 over 1 is 6. So if we have a little polar grid, which I have drawn on your homework for you for the artistically challenged. So we're going to have 0, 3, 1, 2, 3. Pi over 2 is going to go out 6. 1, 2, 3, 4, 5, 6. Pi has nothing, and then 3 pi over 2 also goes 6. So if you know that your eccentricity, I guess I should identify K, A, and B. So K is 6, A is 1, B is 1. Our eccentricity is 1 over 1, which is 1. So when that happens, that is the parabola. Now, a parabola has a directrix. We've talked about a directrix like in rectangular coordinates, right? Actually, all of these polar equations have a directrix, which is kind of weird. It's just like this random line, and you're like, wait, what does that have to do with this this shape? So, like a directrix for this one, I believe, is like up here. I mean, you don't have to worry about the directrix for any of those. But if I ask it for a parabola, I think you guys can handle that. All right, so show algebraically that the graph is a parabola by transforming into rectangular forms. That's the hard part, remember? So we're going to multiply the denominator over. So when we do that, we get r plus r cosine of theta equals 6. So we're going to have the square root of x squared plus y squared plus x equals 6. We subtract the x over, so we have 6 minus x. And we have the square root of x squared plus y squared. And we square both sides. So when we do that, we get x squared plus y squared. And we FOIL it out. So we're going to have 6 minus x times 6 minus x, 36 minus 12x plus x squared when we FOIL it. And you'll notice that the x squareds go away, right? If I subtract x squared from both sides, yay, gone. So we have a y squared equation. Y squared equals something with just x. So we can tell that it's a parabola. Can you guys all tell it's a parabola? So remember, our parabola form, I always say a little bit of flare on both sides. One of them has a square, one of them has a 4p. So what we're going to do to get this in the form is we're going to do y squared equals, and I'm going to do negative 12x plus 36, and I'm just going to pull out that negative 12. So I'm going to have x minus 3. So would you be able to identify the vertex of this ellipse? No, Williams, you with me? So the vertex would be what? 3, 0. What would p be? P would be like 3 or negative 3, right? We would call it negative 3. And would it open right, left, up, or down?
Left.
It would open left. Good. So you would be able to sketch that out from that. Does it make sense that it would be exactly what this one is? Right, 3, 0. Isn't that the rectangular coordinate 3, 0 for the vertex? Totally. Yep. And then remember, the focus is always at the pole. There's our focus. Do we have another focus for a parabola?
No.
Nope, just that one. So its eccentricity was 1. The focus was just the one at the pole, 0, 0. Your vertex, it's always hard because you're like, I want to write it as 3, 0. It actually is 3, 0, r, theta. Zeros are theta. But be careful if it's a vertical one. Remember, you're going to have something pi over 2. And then the directrix. What about the directrix?
0, 6.
Yeah, it's like it's out at 6, and it would be this vertical line right here. So really, in rectangular, we would write it as x equals 6, but that's rectangular. How do you think we would write it in polar? What would we replace the x with? R cosine of theta equals 6. So how do I write that vertical line then? It'd be 6 divided by cosine, which is going to be 6 times secant theta. That would be the way you would write that directrix.
Why isn't it 7? Because I thought, never mind.
You got it? All right, that's the last one, right? Yep, okay. Any questions on any of that? It's different. I didn't learn this when I was in school, actually. I learned it after, and I was like, huh, I didn't know you could do conic sections and polar coordinates. I think it's kind of a cool little thing. You guys may not think it's cool. My definition of cool is different.